The commander of U-264 stood in his cramped control room on the night of February 7, 1945, 30 miles northwest of the Scilly Isles, and believed he was invisible. His boat had been snorkeling for 6 hours, diesel engines rumbling below, drawing air through the tube that projected barely a meter above the surface. The crew endured the familiar miseries. The throbbing headaches from carbon monoxide seeping through imperfect seals, the violent pressure changes when waves closed the valve atop the snorkel head, the nauseating rise and fall as the boat maintained periscope depth in heavy seas. But these discomforts seemed a small price for safety. The British could not see them. The Schnorchel had made them invisible to the enemy that ruled the skies above the Atlantic. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. At 2300 hours, the hydrophone operator reported propeller sounds. Fast screws closing from the south. The commander ordered the Snorkel retracted and took his boat deep, standard procedure when surface vessels approached. What he did not know, what he could not have known from his position 60 meters below the surface, was that the British frigate bearing down on his last known position had been tracking his snorkel head on radar for the past 40 minutes from a range of 12 miles. The Centimetric radar set aboard that frigate, operating at a wavelength of 10 centimeters, had painted his snorkel as a clear contact on the operator's scope, while U-264's commander congratulated himself on remaining undetected. This was the central contradiction that would define the last year of the U-boat war. German Naval Command had issued the Schnorchel to hundreds of U-boats, promising crews that the device would restore their ability to operate in Allied-controlled waters. Engineers explained that by running submerged on diesel power, boats would avoid detection by aircraft that had made surface running suicidal. Crews believed them. They had to believe them because the alternative was accepting that they were being sent to sea in vessels that could no longer survive in the waters they were ordered to patrol. But the promise was false. The Schnorchel did not make U-boats invisible. It made them differently visible, and Allied radar operators had learned to recognize the distinctive signature of a snorkel head cutting through surface waves. The technology that was supposed to save the U-boat force had become another way to die. Crews endured brutal conditions underwater, breathing poisoned air, suffering equipment failures, developing psychological disorders from weeks spent submerged, all while believing they were safe from detection. And above them, Allied aircraft and surface vessels tracked their snorkel heads with radar sets operating at wavelengths the Germans had not anticipated. The mathematics were merciless. A snorkel head presented a radar cross-section measurable in square meters. Centimetric radar could detect such targets at ranges that gave Allied forces ample time to maneuver into attack positions. The submarine that thought itself hidden was actually broadcasting its position to any properly equipped enemy within a dozen miles. This is the story of how German U-boat crews discovered that their salvation was an illusion, that the device meant to protect them had simply changed the nature of their vulnerability, and that the technological race they thought they were winning had already been lost before most of them ever put to sea with a Schnorchel fitted to their boats. Part 2. Building the World Context and Ideology, 600 words. To understand why German submariners placed such desperate faith in the Schnorchel, one must first understand what had been taken from them. The U-boat force that entered the Second World War in September 1939 was designed for surface operations. Submarines of that era were more accurately described as submersibles, vessels that operated primarily on the surface and submerged only to attack or evade. The Type 7 U-boat, which would become the workhorse of the German fleet, could make 17 knots on the surface using its diesel engines. Submerged, running on battery power, it managed only 7.5 knots for limited periods before the batteries required recharging. This required surfacing and running the diesels, which recharged the battery banks while also allowing the boat to make good time toward patrol areas or away from danger. For the first 2 years of the war, this arrangement worked splendidly. U-boat commanders called the period from June 1940 through February 1941 the happy time, when British convoy defenses were inadequate and German submarines roamed the North Atlantic with relative impunity. Boats surfaced at night to attack convoys, using their low profiles and the darkness to close undetected. They dove during daylight hours, waiting for nightfall to resume hunting. A commander could expect to survive his patrol, return to base, and deploy again with reasonable confidence in coming home. Crews developed skill and experience. Tonnage sunk climbed month after month. Admiral Karl Donitz, commanding the U-boat force, believed that with sufficient boats he could strangle Britain's maritime supply lines and win the war. Then the technological balance shifted. The British deployed increasingly sophisticated radar sets to their escort vessels and aircraft. Early metric wavelength radar, operating at 1.5 meters, could detect a surfaced U-boat at several miles range in good conditions. By 1941, modified ASV Mark II radar aboard Coastal Command aircraft made surfacing dangerous even at night. U-boats that had hunted freely now found themselves hunted. Commanders who surfaced to charge batteries risked immediate detection and attack by aircraft they never saw coming. The loss rates began to climb. The situation deteriorated catastrophically in 1943. The Allies introduced centimetric radar, operating at wavelengths of 10 centimeters and later 3 centimeters. These sets, far more precise than their metric predecessors, could detect even the small silhouette of a U-boat's conning tower from ranges that left commanders with no time to dive before aircraft arrived overhead. Simultaneously, Allied escort groups became more numerous and better equipped. Destroyer and corvette screens around convoys thickened. Support groups with dedicated hunter-killer vessels hunted U-boats between convoy routes. Very long-range aircraft, particularly B-24 Liberators, closed the mid-Atlantic air gap, where U-boats had previously found refuge beyond the range of land-based aircraft. In May 1943, Donitz withdrew his boats from the North Atlantic after losing 41 submarines in a single month. The previous standard of operations, surfacing to transit and to charge batteries, had become a death sentence. U-boats needed some method to run their diesels without exposing the entire boat to radar detection. They needed to breathe while remaining submerged. Without such capability, the U-boat force faced obsolescence. Hundreds of boats, thousands of trained crewmen, the entire infrastructure of bases and supply, all of it was useless if submarines could not operate in the waters where Allied shipping sailed. The Schnorchel seemed to offer exactly what was needed, a way to restore the U-boat to relevance in a war that had moved beyond the limitations of its original design. Part 3. Building the World, the Schnorchel Solution, 600 words. The technology itself was not German. Dutch submarine designers had developed the Snorkel concept in the late 1930s, fitting their boats with retractable air intake tubes that allowed diesel operation while submerged at periscope depth. When Germany invaded the Netherlands in May 1940, the Kriegsmarine captured several Dutch submarines and examined their systems with interest, but initially saw no urgent need for the technology. German U-boats were winning the Atlantic battle with conventional tactics. The Snorkel was noted, filed away, and largely forgotten. By 1943, desperation made the forgotten suddenly essential. German engineers retrieved the Dutch designs and began development of what they called the Schnorchel, from the German word for snout or snorkel. The device consisted of 2 tubes mounted on a hinged mast that could be raised or lowered from inside the submarine. The larger tube, approximately 25 centimeters in diameter, served as the air intake for the diesel engines. The smaller tube, roughly 15 centimeters across, expelled exhaust gases. At the top of the intake tube was a float valve designed to close automatically when waves washed over the head, preventing water from flooding into the boat. The concept was mechanically simple, but operationally complex. A U-boat equipped with a Schnorchel could maintain periscope depth, approximately 15 meters below the surface, with only the snorkel head exposed above the waves. In this configuration, the boat could run its diesel engines to charge batteries and make moderate speed, typically 5 to 6 knots. The snorkel head projected approximately 1 meter above the surface when fully extended, presenting a minimal visual signature even in daylight. In darkness or rough seas, the head was nearly invisible to lookouts on surface vessels. German naval engineers calculated that this minimal exposure would defeat Allied radar. They understood that the British and Americans had developed improved radar sets, but assumed these sets were optimized for detecting large surface targets like ships or the full profile of a surfaced submarine. A snorkel head, they reasoned, presented such a small radar cross-section that it would be lost in sea clutter. The radar returns from wave tops and surface irregularities that created false contacts on operator scopes. Even if the snorkel head did create a radar return, engineers believed it would be indistinguishable from the general clutter of the ocean surface. This assumption was reinforced by the German Navy's own radar development experience. German radar technology had focused on longer wavelengths, where the physics of wave interaction with small objects made detecting something as small as a snorkel head extremely difficult. German engineers, working within their own technological framework, could not conceive of radar sets sensitive and precise enough to reliably detect and track a target measuring less than 1 meter across at ranges of several miles. It seemed physically implausible. Production of Schnorchel-equipped U-boats began in earnest in mid-1944. Retrofit programs added the device to existing boats returning to port. By autumn of that year, the majority of operational U-boats either had Schnorchel installed or were scheduled for installation during their next maintenance period. Crews received training in the new procedures. Commanders learned the techniques of maintaining depth while snorkeling, managing the diesel loads to avoid dangerous pressure fluctuations when the float valve closed, and dealing with the inevitable mechanical problems that arose from operating complex machinery in the hostile undersea environment. The U-boat force believed it had found salvation. Donit's staff calculated that with Schnorchel technology, submarines could return to offensive operations in Allied-controlled waters. Boats could patrol submerged for extended periods, surfacing only in rare emergencies. The advantage had shifted back toward the submarine. Or so they believed, right up until Allied radar operators began reporting consistent contacts on small surface targets in known U-boat operating areas, contacts that behaved exactly like submarines trying to hide. The experience of snorkeling was nothing like surface operations. A U-boat commander raising his Schnorchel for the first time discovered immediately that the device brought its own catalog of miseries, each of which his crew would come to know intimately over the weeks and months ahead. The process began with the boat at periscope depth, approximately 15 meters below the surface, trimmed carefully to maintain precise depth control. The Schnorchel mast was raised hydraulically, a process that took approximately 30 seconds. Once the head broke the surface, the diesel engines could be started. On a Type 7 U-boat, the two six-cylinder diesels required approximately 400 cubic meters of air per hour when running at cruising power. This massive volume was drawn through the intake tube, creating a continuous rush of air through the boat that made normal conversation difficult. When the float valve at the top of the intake tube closed, either from a wave washing over it or from the boat dropping below proper depth, the diesels continued to draw air from the only available source, the interior of the submarine. The pressure inside the boat dropped rapidly. Crewmen felt their eardrums flex inward. Some experienced severe pain. A few suffered ruptured eardrums. The pressure drop could reach half an atmosphere in seconds before the engine room crew could shut down the diesels or the valve reopened. Then the cycle would repeat minutes later when another wave closed the valve. Carbon monoxide was the constant companion of snorkeling operations. Despite the exhaust tube, diesel fumes seeped into the boat through imperfect seals and gaskets. The concentration was rarely high enough to cause immediate unconsciousness, but it was more than sufficient to produce crushing headaches, nausea, and dulled thinking in men who needed to remain alert. Crew members developed a gray pallor after days of snorkeling. Some vomited repeatedly. Others reported visual disturbances and difficulty concentrating. The boat's medical officer had no treatment except to recommend that men rest when possible, advice that was useless when every crew member was needed to maintain the complex ballet of keeping a submarine at precise depth while operating machinery designed for surface use. The depth keeping itself demanded constant attention from the control room crew. A submarine at periscope depth in Atlantic swells rose and fell with each passing wave. If the boat went too deep, the snorkel head dipped below the surface and the float valve closed. If the boat rose too high, the conning tower or even part of the hull might break the surface, creating a visual signature or a radar return far larger than the snorkel head alone. The plainsman stood at their controls for hours, making continuous tiny adjustments to the hydroplanes, compensating for changes in the boat's trim as fuel and water were consumed and shifted, fighting the ocean's constant attempt to push the submarine either down into the depths or up toward the lethal surface. Commanders quickly learned that snorkeling in rough seas was brutal. The snorkel head, pitching violently as the boat rode the swells, would dip under repeatedly. The float valve would slam shut. The pressure would drop. The diesels would labor. Men would gasp and hold their ears. Then the valve would open and the cycle would begin again. In truly heavy weather, snorkeling became impossible. The boat had to either surface, accepting the risk of radar detection, or remain deep on batteries until conditions improved. What commanders did not learn What they had no way of learning from inside their steel cylinders beneath the waves was that every time they raised their Schnorchel head above the surface, they became visible to an enemy whose detection capabilities far exceeded anything German intelligence had anticipated or German engineering had prepared them for. Part 5. The Deep Dive Allied Radar Capabilities, 600 words. The radar set that made snorkel detection possible was the ASV Mark III, developed by British scientists and engineers working at the Telecommunications Research Establishment. The designation ASV stood for Air-to-Surface Vessel, indicating its primary purpose: detecting submarines from aircraft. The Mark III operated at a wavelength of 10 centimeters, a dramatic reduction from the 1.5-meter wavelength of earlier radar sets. This shift to centimetric wavelengths was made possible by the cavity magnetron, a device developed at the University of Birmingham in 1940 and refined into a practical, mass-producible component by 1942. The physics of centimetric radar fundamentally changed what could be detected at sea. Longer wavelength radar suffered from sea clutter. The collective radar returns from wave crests and surface irregularities that created a confusing mass of contacts on the operator's scope. A small object like a periscope or snorkel head disappeared into this clutter, indistinguishable from the random returns generated by the ocean itself. But 10-centimeter radar, operating at a frequency of 3,000 megahertz, had a wavelength short enough that it reflected differently from wave surfaces. The returns from smooth water were minimal. Returns from solid objects, even small ones like a snorkel head cutting through the surface, stood out distinctly on the operator's scope. By late 1943, ASV Mark III sets were being fitted to RAF Coastal Command aircraft as rapidly as production allowed. By mid-1944, virtually every anti-submarine aircraft operating over the Atlantic, the Bay of Biscay, and the North Sea carried either the British Mark III or the American ASV Mark IV, a derivative design. Later variants, operating at 3-centimeter wavelength, offered even better discrimination between targets and sea clutter. The H-2S Mark III radar, originally designed for navigation and bombing, proved remarkably effective at detecting snorkel heads when fitted to maritime patrol aircraft. The detection ranges were significant. Under good conditions, with calm seas and clear weather, an experienced radar operator could detect a snorkel head at 12 to 15 miles. In moderate seas, the range decreased to 8 to 10 miles. Even in heavy weather that created substantial clutter, a snorkel head that remained above the surface for more than a few seconds could be detected at 4 to 6 miles. These ranges gave aircraft crews ample time to maneuver into attack positions before the U-boat could detect the approaching aircraft and dive to safety. Surface vessels received similar radar improvements. The Type 271 radar, fitted to many British frigates and destroyers by 1944, operated at 10 centimeters and could detect snorkel heads at ranges of 6 to 8 miles in good conditions. Smaller escort vessels received the Type 291 set, slightly less capable but still effective at ranges of 4 to 6 miles. American destroyer escorts and patrol craft were equipped with comparable sets, the SG Surface Search Radar and later the SO1 model, both operating at 10 centimeters. Radar operators learned to recognize the distinctive signature of a snorkel contact. Unlike a surface ship, which presented a large, stable radar return, a snorkel head created a small, intermittent contact that appeared and disappeared as the submarine rose and fell with the swells. The contact was never strong, rarely more than a faint blip on the scope, but it had a characteristic behavior. It moved steadily in one direction at speeds consistent with a submerged submarine making transit speed. It did not drift like wreckage or flotsam. It maintained course for minutes or hours at a time. Experienced operators could distinguish a snorkel from sea birds, floating debris, or wave anomalies with reasonable confidence after observing the contact's behavior for a few minutes. Allied anti-submarine forces developed standard procedures for prosecuting snorkel contacts. Aircraft approaching a radar contact would descend to visual search altitude, attempting to sight the snorkel head visually for positive identification. Part 6. Collision with Reality. The attacks begin, 600 words. U-248 was snorkeling 80 miles west of Brest on the afternoon of August 3, 1944, when a Halifax bomber from No. 502 Squadron appeared without warning. The aircraft came in low and fast from the stern quarter, giving the lookouts no time to sound the alarm before the bomber was overhead. The commander, Oberleutnant Zur C. Clemens Scholar, had the snorkel down and his boat diving toward 100 meters within 45 seconds of the first shout from the bridge. Depth charges detonated around the boat as it descended. The explosions were close enough to crack light fittings and jar equipment loose from mountings, but U-248 survived. Scholar kept his boat deep for 4 hours before cautiously returning to periscope depth to assess the situation. What Scholar could not know was that the Halifax had detected his snorkel head on ASV Mark III radar from a range of 11 miles. The radar operator had watched the contact for 8 minutes, tracking its steady movement northward at 5 knots, before the pilot maneuvered into attack position. The visual sighting of the snorkel head confirmed what the radar had already told them. A U-boat was below, running submerged on diesels, completely unaware that it had been under observation for nearly a quarter of an hour. Similar incidents multiplied through August and September of 1944. U-482 was caught snorkeling in the English Channel on September 11th and sunk by depth charges from RAF Liberators that had tracked the boat's snorkel on radar. U-871 was attacked while snorkeling off the Hebrides on September 26th. The boat survived but sustained damage that forced it to abort patrol and return to base. U-1226 was sunk by a Canadian frigate on October 6th after the surface vessel detected and tracked the submarine's snorkel for 40 minutes before closing to attack range. The evidence accumulated in the patrol reports of boats that returned to base. Commanders described being surprised by aircraft while snorkeling in conditions they had believed safe. They reported attacks that came without the usual warning signs, without the sound of aircraft engines that might have given them time to dive. They noted that attacks seemed to occur more frequently when snorkeling than when running deep on batteries. The pattern was clear to anyone examining the data objectively. Snorkeling did not provide protection from detection. But German intelligence struggled to understand the mechanism. Interrogators questioned captured Allied aircrews about their detection methods and received answers that seemed implausible. The British claimed they could detect submarines on radar at ranges of 10 miles or more. German radar specialists, familiar with their own metric wavelength sets, found this difficult to credit. A snorkel head presented such a small radar cross-section. The sea clutter should overwhelm any returns from such a tiny target. The mathematics didn't support the Allied claims. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. It was not until late 1944, when technical intelligence officers examined captured British radar equipment from a downed aircraft, that German engineers began to understand what they faced. The cavity magnetron, the compact, efficient device that generated 10-centimeter wavelength radar pulses, was a technology Germany had not successfully developed. German radar research had pursued different paths, focusing on longer wavelengths and different applications. The centimetric radar that had become standard equipment throughout the Allied air and naval forces represented a technological leap that German industry had not matched and German military planning had not anticipated. The implications were devastating. The Schnorchel, the device that was supposed to restore U-boat effectiveness, had been compromised before it entered service. U-boat crews continued to snorkel through the final months of the war, not because the technology protected them, but because they had no alternative. The order to remain submerged except in absolute emergency came from BDU, the U-boat command headquarters. Commanders who surfaced to charge batteries or make better speed risked immediate court-martial if they survived the patrol. The official doctrine held that snorkeling, despite its discomforts and occasional detection, remained safer than surface operations. This was true only in the narrow sense that a boat detected while snorkeling at least had the option of diving to safety, while a boat caught on the surface had no such option. But the psychological cost of operating under this compromise was severe. Crews knew they were being detected. Patrol reports from returning boats made this clear. Yet each time a commander raised his Schnorchel, he had to proceed as though he were safe, as though the device was working as promised, because acknowledging the truth meant acknowledging that he was leading his crew into waters where detection was likely and escape uncertain. The cognitive dissonance was crushing. Men endured carbon monoxide poisoning, pressure changes that ruptured eardrums, and weeks submerged in fetid air, all while knowing that the suffering purchased them only partial concealment at best. The medical effects of extended snorkeling became impossible to ignore. Crews returning to base after patrols of 4 to 6 weeks showed symptoms of chronic carbon monoxide exposure. Headaches that persisted for days after returning to port, difficulty concentrating, memory problems, muscular weakness. Some men reported visual disturbances that continued long after they left their boats. The gray skin tone that characterized snorkeling crews became so common that shore-based personnel could identify a boat's crew as having just returned from patrol simply by their appearance. Psychological casualties increased. Men who had functioned effectively on earlier patrols broke down after weeks spent submerged. The claustrophobia of submarine service, always present, intensified when boats remained submerged for 30 or 40 days at a stretch. Some crew members became unable to perform their duties. Others developed what the boat's medical officers described as severe anxiety states, manifesting as tremors, inability to sleep, and panic reactions to routine events like the float valve closing. These men were invaluable, trained specialists who could not be easily replaced, yet they were being destroyed by the conditions they endured. Commanders faced impossible choices. Every time they raised the Schnorchel, they risked detection. Every time they remained deep on batteries, they depleted the electrical capacity they would need for evasion if attacked. The optimal solution, running on the surface at night to charge batteries and make good speed, was forbidden by standing orders. They operated within constraints that made effectiveness nearly impossible while taking casualties that made continued operations unsustainable. The loss rates told the story in numbers immune to interpretation. In 1944, after Schnorchel deployment became widespread, Germany lost 241 U-boats. In the first 4 months of 1945, before the war's end, an additional 153 boats were lost. Not all these losses occurred while snorkeling, but a substantial fraction involved boats detected and attacked while running submerged on diesels, boats whose commanders believed they were safely hidden beneath the surface. The Schnorchel had not restored U-boat effectiveness. It had simply changed the circumstances under which crews died, substituting slow suffocation and poisoning for the quick violence of surface attacks, while providing the illusion of protection that made continued operations psychologically possible for men who might otherwise have refused to go to sea in vessels that could no longer accomplish their mission. Part 8. The Cost of Truth Final Operations, 600 words. By March 1945, U-boat operations had contracted to a shadow of the force that had terrorized Atlantic convoys 3 years earlier. The boats that remained operational patrolled in waters close to the British Isles and in the shallow coastal areas where Allied anti-submarine forces were thickest. This was not strategic calculation but necessity. The fuel situation had become so critical that boats could barely reach distant patrol areas. The crew situation was worse. Experienced personnel were dead or in prison camps. Replacements came from shortened training programs that produced men technically qualified but utterly unprepared for the reality of combat operations under conditions where detection meant death. U-2321 departed Bergen, Norway on April 7, 1945, under the command of Oberleutnant Zursee Hans-Heinrich Henson. The boat was one of the newer Type XXI electro boats, designed specifically for underwater operations with massive battery capacity and streamlined hulls optimized for submerged speed. But even this advanced design required snorkeling for extended patrols, and U-2321 carried the standard Schnorchel installation. Henson's patrol orders directed him to operate off the Firth of Forth, attacking any Allied shipping he could find. He was detected by RAF liberators on 3 separate occasions while snorkeling during his transit north. Each time he evaded attack by diving to his boat's maximum operating depth and remaining there until his batteries were nearly exhausted. On April 18th, he was detected again by a surface vessel whose radar tracked his snorkel from 8 miles distance. This time the attacking destroyer caught U-2321 before the boat could reach safety. Depth charges detonated around the diving submarine. The boat's hull cracked under the pressure. She sank with all hands, 48 men who died never having fired a shot at an enemy vessel. U-3708 was caught snorkeling in the North Sea on April 21st. U-2336 was sunk off the Norwegian coast on April 30th while attempting to charge batteries. U-3515 survived until May 4th, when British frigates detected her snorkel and prosecuted the contact until the boat's batteries were exhausted and she was forced to surface. The crew scuttled their boat rather than surrender, though most of the men survived to become prisoners. These were the last U-boats lost in combat, destroyed in the final days of a war that was already decided, killed while performing the routine operation that was supposed to keep them safe. When Germany surrendered on May 8, 1945, approximately 150 U-boats remained operational. Most were scuttled by their crews under Operation Regenbogen, the directive to destroy all boats rather than allow them to fall into Allied hands. A few surrendered intact and were turned over to Allied navies for examination. Technical intelligence teams studied the Schnorchel installations with interest. They found well-engineered systems, carefully designed and competently manufactured. The Dutch had created a sound basic concept. German engineers had refined it and made it producible. But the fundamental limitation remained. The Schnorchel head, when raised, presented a radar target that centimetric radar could detect at ranges that negated the device's protective value. Post-war analysis confirmed what the loss rates had suggested. Schnorchel-equipped boats had lower survival rates than conventionally operated submarines in the early war years. The technology had not saved the U-boat force. It had simply allowed operations to continue under conditions where they could not succeed, prolonging the agony for crews sent to sea in obsolete vessels against an enemy whose technological superiority made the outcome inevitable from the moment they deployed. Part 9. Legacy and Reflection. The Mathematics of Defeat, 600 words. The story of the Schnorchel is not primarily about technology. It is about the gap between what a military force needs and what it can actually produce when fighting an enemy with superior industrial capacity and more advanced research capabilities. Germany needed submarines that could operate undetected in Allied-controlled waters. What it produced was a device that reduced but did not eliminate detectability, while imposing severe operational penalties on crews who used it. The gap between need and capability, between promise and performance, killed thousands of men who believed the equipment they were given would protect them. The Allied advantage in centimetric radar represented more than a single technological breakthrough. It represented a systematic investment in scientific research, rapid development of laboratory discoveries into mass-producible equipment, and efficient deployment of that equipment throughout air and naval forces. The cavity magnetron was not invented in a vacuum. It emerged from research institutions like the University of Birmingham, was refined by organizations like the Telecommunications Research Establishment, was manufactured by companies like General Electric Corporation and Western Electric, and was installed in aircraft and ships by maintenance crews who had been trained to service and repair the complex electronics. Every step of this process required coordination, resources, and technical expertise applied at scale across multiple nations and military services. Germany had capable scientists and engineers. German researchers understood the theoretical physics of centimetric radar. But understanding the theory and building a functional, deployable system at scale are different problems requiring different capabilities. Germany in 1943 and 1944 was a nation under siege, with its industrial cities being bombed, its transportation network being disrupted, its access to raw materials being restricted by Allied naval and air superiority. The institutional and industrial capacity to develop and deploy centimetric radar at the speed and scale the Allies achieved simply did not exist within the constraints Germany faced. The U-boat crews paid the price for this disparity. They went to sea with equipment their nation could produce, not equipment that could actually accomplish the mission they were assigned. They endured brutal conditions, breathed poisoned air, suffered medical complications, and died in waters their commanders assured them they could patrol safely. All because the alternative was admitting that the war at sea was lost and no technology available to Germany could change that reality. U-264, the boat whose commander believed himself invisible while British radar tracked his Snorkel from 12 miles away, survived its February 1945 patrol. The boat returned to base, refueled, took on supplies, and deployed again in March. It was detected while snorkeling on March 19th by a British frigate operating off the Irish coast. The frigate prosecuted the contact with depth charges and hedgehog mortars. U-264 was sunk with all 48 crew members. The commander who had congratulated himself on remaining undetected died, never knowing that the enemy had been watching him for months. Tracking his movements with radar technology his intelligence officers insisted could not detect a target as small as a snorkel head. This was the final illusion that killed the U-boat force. The belief that German engineering had found a solution, that the Schnorchel restored the submarine to effectiveness, that the crews who endured its hardships were purchasing safety with their suffering. They were not. They were broadcasting their positions to an enemy who could see them clearly while they believed themselves hidden, dying in machines that promised protection but delivered only new ways to be killed. The mathematics were unforgiving, and they were decided before most of the men who died ever put to sea. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.